Hello, and in this video, I'm going to show you how the forces that hold atoms together within molecules can be represented as a spring, and thereby sort of motivate why springs are so important and why we'll spend so much time in this class talking about springs. And to do that, I'm going to be using this atomic interaction simulation from PhET. The simulation is embedded in your book just below this video, and I would encourage you to open it up and play with it. So when you open it up, this is what you'll see. And what we're looking at here are two neon atoms. Now, this isn't very realistic because, as we all know, neon atoms don't really interact with each other very much. I mean, they're noble gases. Not much goes on. So let's change things a little bit. Let's go to a real molecule, diatomic oxygen, so O2, right? And in this slightly simplified version of molecular oxygen, the molecule on the left is pinned down. You can see the little pin here. So that means it's not going to move at all. The one on the right, on the other hand, I'm free to sort of drag around. And these green arrows show us the force on each molecule. If you want to turn that on, you use this little menu and click total force, right? And so you can see that if I separate the molecules, then there is a force which pulls them back together. In contrast, if I get them too close together, then the overlap of their electron clouds causes them to repel. And it's even possible to get these two molecules to bounce. So it really does act like two balls on the end of a spring here. It's the exact same sort of phenomenon, right? You've got my two atoms, and the bond in between them acts as a spring. If I pull the atoms apart, then the bond, or the spring in this case, pulls them back together. In contrast, if I squeeze the atoms too closely together, the electron clouds start to overlap and force the atoms back apart. Hopefully, this motivates one of the reasons why we're so interested in studying springs in this class. This concludes this video.